Hello everyone, welcome back to MindSpread. The chances are you have seen formulas like these before. But how do these formulas work? They pop up everywhere in physics, engineering, and other fields of science that are similar. But why? Is there a more intuitive way to understand the maths behind all these different scientific fields? A way we could potentially actually see the math? Now the reason for why we would want to do that was given in my actual very first video, so I'm not going to go over that again. But briefly speaking, the universe has a consistency to it, and math is a way of studying those consistencies. There are four basic fundamental operations in maths, and they're shown on the screen. Now using these operations on things like x and y, it's not a concept too hard to grasp. But when we start to apply it to things like in physics, like volume and mass, what does it actually mean to multiply or divide volumes and mass? What are we actually doing to the system? Well, to answer this sort of question, let's take a step back and look at something simpler. Addition. What does it mean when we add two quantities together? Imagine that we had two black dots and I wanted to add that to three other black dots. That would be in total 5 dots. Now what we've done here is counted together the 2 dots and the 3 dots to make 5 dots. But there's another way to look at this. We've basically unified together the 2 dots and the 3 dots to make 5 dots. Those 5 dots are the unification of the 2 and 3 dot system. There is a rule to addition, and that is you can't add different entities together. Take the example below. If I tried to add together a cup and a mug, you'd only ever get cup plus mug. You would never get something else. And that's because cup and mug are two separate entities. But we can define as units. Let's say the cup has 1 unit of liquid and the mug has half a unit of liquid. Then we can add those units together to get 1.5 unit of liquid. This works because the units of liquids are considered the same entity. Okay, so where does this come in use? Well, let's look at the internal energy, which is the total energy subject to a system. That's defined as the kinetic energy plus the potential energy. The kinetic energy is the energy due to its motion, and potential energy is the energy due to its position in some sort of field. Here, a field is defined as a thing which varies through space. Take for example the gravitational field, which allows us to have gravitational potential energy here on Earth, because the position of an object in that field tells us how much potential energy it has. Now the reality is, you've probably heard of different sorts of energies, such as sound, heat, electrical, light, the list goes on. All these different energies are just different permutations of kinetic and potential energy. Kinetic energy being the energy due to motion, and potential energy being the energy due to an object's position within a field. Given all of this information, the internal energy of a system is basically the kinetic and potential energy unified together. Coalescing both of these energies together gives you the total energy a system has, also known as the internal energy. And this is what the addition operation allowed us to do. Note that kinetic energy and potential energy are measured with the same units. Okay, so let's look at something more interesting. Multiplication. What does multiplying stuff do? We will use this famous formula, force equals mass times acceleration, to show you. The definitions are given below the formula. To understand multiplying, pretend we have this object and it's accelerating. We want to know the force acting on the object, so the capacity of this object to change its motion when not resisted. Okay, so first let's begin by defining the object. We're going to define this object by its mass, because that's the amount of matter it's made out of. But how do we agree on the mass of this object? We could compare its mass to a dumbbell, or we could compare its mass to a chair. Maybe the square weighs the same as a dumbbell, or half the weight of that chair. So a problem has arisen. We need a way where we can all agree on the unit of mass to use. And a big mistake was made, well, a $125 million mistake was made when the Mars rover crashed, because scientists were using different units and they forgot to convert between those units and they got the wrong outcome. So for this example, I'm going to use the unit kilogram. Let's say this object's made of 4 kilograms, broken up into those 4 smaller squares. Now let's decide this object's acceleration. Now we have the same problem with units for acceleration as well. We need to confirm what units we're using. In this case we'll use meters per second squared. Let's say this object is accelerating at 2 meters per second squared, made of the units meters per second squared. Now a force is a measure of the capacity for an object to change its motion when not resisted. Now because we broke this object down into unit kilograms, all those unit kilograms have to all accelerate at 2 meters per second squared. I can't just have 1 unit kilogram accelerating, otherwise the object would just fall apart. So in actuality, the entire 4 kilograms of this object is going to accelerate at 2 meters per second squared, and it would look like this. What's interesting is if you count the meters per second square arrows, you have 8 of them. And if you multiply 4 by 2, you also have 8. So plugging in the numbers in the formula gives you the force of 8 kilograms meters per second squared, or 8 newtons. And counting the arrows in each kilogram also gives you the number 8. So it's like if the formula is saying a force is when a mass has an acceleration. So multiply sign is basically saying that this state or property has this state or property. So mass has a acceleration. So think of multiply as saying has a. What was also interesting, unlike addition where you can only add like units together, in multiplication you can combine different units, different entities together to make brand new entities. So it's almost like it's merging things together, merging states together to make brand new properties or states. On the most fundamental level, multiply means repeat. If I said 3 times 2, the answer would be 6. And the reason it's 6 is because it's 3 plus 3. 3 repeated 2 times, or you can even say the other way around, 2 times 3, which is 2 repeated 3 times, and that would also be 6. So the order of multiplication doesn't matter, and multiply at a fundamental level means repeat, addition. And that's what we did with that force example. We repeated the acceleration for all of its masses. Okay everyone, thank you for watching. Don't forget to subscribe and join me next time where we're going to discuss division and subtraction. I hope it helps, and leave a comment.